Might as well get it done now, I guess. Nah, not feeling it. Or it's not really my thing. I don't know about this one. Yeah, that should be pretty easy. Now at this stage in the video you might be wondering, Ian, why do you need to build another particle simulator exactly? Aren't there enough ones online already? And to that, my dear moron, my answer is... In all seriousness though, I do want to code this particle simulator to be 3-dimensional so that I can outdo the daemon spawn that coded the FET sims, but in order to do that I'm going to have to install a special library called vpython. Now vpython, which I'm downloading right now, is very important because it's going to allow us to render in 3D objects, specifically spheres. And vpython should be simple enough, and I'm a pretty good enough programmer, that with a little practice I should be able to render in spheres of all sizes, shapes, and colors onto my computer screen without any problems whatsoever. Now with a little bit of extra research, I've managed to get the balls to spawn upon the press of a button, and I've also managed to get them to go in 3 dimensions. Now this is going to be the first major test of what we've built so far. Hopefully nothing goes wrong because I haven't tested this yet. And here we go. Oh, no. Oh, no, don't look at that, don't look at that. No. Stop. No, close up. Our next big issue is that the balls don't actually bounce off the walls or each other yet. Now, obviously, we're going to have to code this to fix this issue because in real life, that's not how it... What? Wait. Where'd it go? What? Huh? What? So after I went ahead and debugged my bathroom wall, I coded my program so that now spheres are able to bounce off walls and each other, which is actually a lot easier than it sounds because spheres are the same distance from any location on their surfaces. Here's a quick montage of me coding it. Yeah, I did the fast forward thing. That right there, that took me 3 hours. I miss kindergarten. Anyway, let's go ahead and I don't know. Let's test it. Alright, so I'm adding a ball and it should be going through. Oh no, you've gotta be. Anyway, as you can see here, I actually managed to code it correctly, so now that the balls are able to bounce off not only the walls, but also each other. Look at that, it looks so good, and it's perfectly functional. Now that we've got that working, I want to add some graphical elements called sliders to the GUI so that I can manipulate some values manually. But Ian, this is a particle simulator, what kind of values are there to manipulate? Well, the particles inside the box are going at a certain speed, so I want to be able to manipulate the temperature so that I can make them go to different speed. They're also within a confined box, and I want to be able to change the volume of that box so that I can change the pressure. How's that for an entry impatient? Now, vpython has already set up slider objects for us, all we need to do is call it. So after a lot of testing, I finally figured out that slider and button objects in vpython for some reason don't even have a disabled or enabled property unless you specify it specifically when you're creating the object. So for example, something like this is going to return this error because I only created a disable boolean after it was instantiated. It's actually really weird that the VPython developers did this because in Python it's actually easier to make objects with a set number of attributes rather than having to enable them manually. So I actually have no idea why they did this, because it just really seems like it's making everything less convenient and really more trouble just overall for everyone. Much like the 6-point system that Vista's English department uses, in fact. Anyway, as soon as I figured out that little issue, I was able to add like a ton of new stuff like sliders, buttons, drop downs, all kind of like little quality of life additions to our little program here. Oh yeah, I also figured out you can't actually disable the sliders for some reason. Everything else works except the sliders. I don't know why. So at this point in the video, we've basically accomplished everything we set out to do in the first place, which is basically make a box with balls in it. But then again, all we did really was make a box with balls in it. So because I haven't spent enough time on this pointless project already, apparently, we're gonna add pressure. Now usually I'd calculate the pressure inside a container using this formula right here. What was that? Oh, Peevner, yes, I'd calculate it using Peevner, but that's boring, so we're gonna try something else. What am I doing? So pressure is the ratio between force and area, also known by the formula force equals area times pressure. However, we usually write it as pressure equals force over area. Now, when a particle bounces off a wall, it experiences a change in direction, which means that it experiences a change in momentum. That change in momentum can be translated to an impulse, which can then be used to calculate force through the momentum-force equality. That force can be substituted into the pressure formula, and this, ladies and gentlemen, is the result. Okay, all jokes aside, here's an actual demonstration of how it works. Enjoy. So as you can see here, I've added 10 moles of hydrogen into the box. Note that the temperature is about 100 and the pressure is about 1.5. Now, I'm going to double the temperature, which according to the ideal gas law should double the pressure as well. As you notice, it's going up a little bit. It's going to happen a little bit slowly, but what's happening is that the temperature is increasing, which results in the particles moving faster. Since they have a higher velocity, their momentum is greater, which means that the impulse when they bounce off the walls is also greater. And it's just about done, so you can see that the pressure is about 3, which is double what it was initially. Now, we can also change the volume to change the pressure, and as you can see, I decreased the volume by a factor of half, which should once again double the amount of pressure according to the ideal gas law. And as you can see, it's gone up to about 6 atmospheres. So this is actually pretty cool because it works perfectly according to the ideal gas law. Now I'm going to double the amount of moles of hydrogen, and again, according to the ideal gas law, this should double the pressure, bringing it up to 12, and as you can see, it's hovering just about that value. So this is actually really cool because it's almost a perfect demonstration of how physics works in the real world, and it just basically suggests that my very strange and random approach to calculating the pressure actually did work after all. Are you tired of working with the same old two-dimensional, boring particle simulator every day? Do you want something new, something innovational, something three-dimensional? Well then we've got just the product for you. Hi there, I'm Jero Wang, two-time winner of the Sexiest Man Alive Award and inventor of the Particle Interaction Simulation System. The Particle Interaction Simulation System comes with multiple strange-looking buttons and sliders for all your needs, a strange-looking and counterintuitive layout, and even includes a trashy 3D visual system that puts our competitors at Fed to shame. And the best part is, it all comes for the low price of my sanity. So what are you waiting for? Order today. Call 916-70. Hey guys, I actually really enjoyed making this video and editing it and everything, so if you want to see more epic Minecraft content in the future, please make sure to like and subscribe. Oh, there's more. This video is 10 minutes long and it took me 3 days to edit. Give me an A. Let me graduate, please.